Hi everyone. Thank you so much for joining us this afternoon for our Enriched Averages online course. So I'll now hand over to Charlie and Alison.
Today all about averages. So what we wanted to do was we wanted to start by sort of setting the scene a little bit, and then Charlie's going to lead us in a problem after that, and hopefully the problems will prompt some good discussion about the sort of things that we're talking about. So I wanted to start by posing something for you to think about. I want you to imagine that you are taking some sort of a class, and in that class, the teacher says, your grade for this class is going to be based on the class average. And you could also think about if you were to pose this question to your students about your own maths classes. And so my question is this: if that was how the class was going to be graded, if your mark for the class was going to be based on the class average, would you want the teacher to choose the mean, the mode, or the median? So have a think about that, and just maybe pop a comment in the chat if you've got a thought about which of those three averages you would rather be graded on if your personal grade was just going to be a class average grade. So Charlie, have you got any thoughts about this?
Well, you and I talked a little bit about it, and we find it quite a difficult question to answer. So
I think there's a lot that you have to consider for this, and I think people's answer would be different depending on what sort of a class they were in. Because if you were in a class where everybody was quite diligent and worked quite hard and all roughly got the same sort of marks on the test, then you might not mind whether the teacher chose the mean, median, or the mode, because they might broadly be all the same. But if you were in a class where everybody worked really, really hard except one really lazy person who never did anything and always scored 0 on the test, I think you wouldn't want to be judged based on the mean, because you'd have one person pulling the average down. Whereas on the other hand, if you had somebody who always scored 100% on every test, then unless you happen to be that person, you might be quite happy about having them bringing the mean average up. So I think it's really important when we're talking about averages to students that, as well as thinking of the individual averages, we're also thinking about how they represent the underlying distribution and what clues we can get about the way data is distributed if the only thing that we have is mean, median, or mode. Is the chat working? Because nobody's put anything in there yet, and I'm a bit worried that I'm shouting into the void and no one's got anything to say. If you can see the chat. Oh, hello. Yes, we've started getting some responses coming in. Brilliant. So yes, this idea of there being outliers and how they affect averages feels really, really key to me. And it's something that I think informal discussion about can really help. And also the fact that you can have more than one set of data that has the same averages. So in order to be able to comment meaningfully about data, sometimes averages on their own aren't enough. But one thing that I think is going to be a theme of this afternoon's webinar is how we can help students to develop intuition for those three averages, the mean, the median, and the mode, and how changing a distribution will have an effect on the averages. So, Charlie, would you like to kick us off then with our first problem of the afternoon?
And just to add to your comment about asking students about which average they'd like the teacher to use, it occurs to me that along with that could be the suggestion that students might change their behavior in order to raise the average that they've chosen. So perhaps the class would say, right, we want the average to be the mean, and we want everybody who finds maths relatively easy in this class to sit alongside everybody who finds maths relatively hard, and to work together and make sure that nobody gets really low marks in this class. On the other hand, if you've got, say, half a dozen students who always get 100%, you might say, right, teacher, we want you to dedicate all your work, all your attention to these 6 students, and we'll go for the mode. It'd be interesting just to see what kind of discussions this kind of question raises. Okay, back to let's do some maths. Let's look at averages. I think Jane would have sent everybody a link to an enriched problem called M, and M, where you get given the mean, the mode, and the median, and asked to find all the possible examples, all the possible sets of 5 positive whole numbers that meet that criteria. So that problem would be an ideal preliminary problem to do before the problem that we're about to introduce to you, which on the Enriched website is called Unequal Averages. We'll show you later how to find that. And the problem starts like this. You get given 5 positive whole numbers. So they are 2, 5, 5, 6, and 7. And I hope everybody can see what Alison's typing in there. And what I'd like you to do to start with is work out the mean, the mode, the median, and the range of those 5 numbers. And perhaps in the chat say, why do you think that that set of 5 numbers is special? What do you notice about the mean, mode, median, and range of those 5 numbers?
Christian says they're all the same. Karen's pointed out, and Laura, that they are all 5. Mean, mode, median, and range are all 5. Yes, I think we've got a fair amount of consensus here, Charlie, that the mean, mode, median, and range are all the same, and they're all equal to 5.
Okay, so my challenge to you is, can you find other examples of 5 positive whole numbers where the mean equals the mode, equals the median, equals the range? So they don't have to be equal to 5. I just want the mean, mode, median, and range to all be equal. So 5 positive whole numbers. And if you could add them to the chat, I'm going to get Alison in a while to start adding them to the whiteboard for us. So we'll give you a couple of minutes to come up with other examples.
I think while people are starting to come up with their examples, it's interesting to think about what your strategies might be for finding them, and also what strategies you think students might use. And that might differ depending on whether they're used to working on this type of problem, or if this is the first time that they've experienced working on a problem like that. So we are going to be giving some suggestions as to how to get students into this sort of very open-ended question, how to approach things like that if they're perhaps a little anxious or a little reluctant to get stuck into that.
And where it's not immediately obvious how to start.
Right, I'm just clearing the board up a little bit because I think everyone knows what the question is now, so that I can start adding some of the ones that are coming in. So I can see Emma has found one. I'd be interested to know if anyone else has found that as well, which is 1, 2, 2, 2, and 3.
What's interesting about Elizabeth's is that the mean, mode, median, and range are again 5, just like the very first example that we offered. So
I shall write Elizabeth's next to the first example then.
Yes, it's so 2, 5, 5, 6, 7 wasn't the only set of 5 numbers where mean, mode, median, and range were equal to 5.
Which kind of highlights this idea that just the averages and range on their own don't give us the full information about a set of numbers. Jack's come up with a suggestion: 5, 10, 10, 10, and 15. So I'll pop that up as well.
I think Laura's offered a suggestion where the mean, mode, and median are all the same, but unfortunately the range is not the same as the mean, mode, and median.
Okay, I'm just thinking about how I would handle that in the classroom, Charlie, and I think I would be tempted to set aside an area on my whiteboard. So writing these things up on the whiteboard is exactly what I would do in the classroom. I would want to bring together everybody in the class's ideas so that as a class we have ownership of them. And so if there are non-examples as well as examples, I think I would want to draw attention to those, not to embarrass or make Laura feel ashamed of herself. Yes, it has been a long day, Laura. But rather to look at what is the mistake that's been made and how can we avoid making this mistake in our other examples. So I might be tempted to collect it as a non-example at the bottom of the page and just put the 2, 3, 3, 3 and 4 there, and then put something like range, that the range is not 3.
I wasn't trying to embarrass Laura, but I think Laura is trying to do something that's possibly impossible. I'm not sure that we can find 5 positive whole numbers where the mean, mode, median, and range are all equal to 3. So I think Laura set herself a really difficult challenge. If we don't accept if we only allow one mode and we only allow positive whole numbers, then I think it may be impossible. I mean, somebody might try to prove me wrong here.
So with that, Indika's suggested something 26688, and if that came up in the classroom, I would again put it up on the board, but I would say that this is bimodal, and that's giving me an opportunity to introduce the idea of a bimodal distribution, that there are 2 modes to that. So for this activity, we're not going to count it, but it's given me an excuse to explain to students that sometimes distribution will have more than one mode, whereas it's got to have exactly one median and exactly one mean.
Looking at Laura's again, I wonder whether anybody can suggest how we can change it if you don't have to stick to the criteria that all 5 numbers need to be positive whole numbers. So can we have mean, mode, median, and range equal to 3 if I relax the conditions and I let you have fractions or decimals, non-whole numbers?
Katie's suggested a couple of good ones. So I'm trying to keep track of chat and write things up at the same time.
Yes.
So Katie sent several. So 4, 6, 7, 7, 11. I'll put up. I think that works, doesn't it?
Yes, and Richard just above her also.
What was Richard's?
Also had a mean, mode, median, and range of 7.
Okay. Was it the same numbers?
No.
Oh, I've got it. I scrolled up to it. 3, 7, 7, 8, and 10. Okay. Oh, we're getting loads coming in now.
And I think somebody has helped answer Laura's challenge of having.
Yes, a couple of people have. Yes. Well done,
Yeah.
Anum and Emma. So I've got 1.5, 3, 3, 3, and 4.5. But I feel as if I should put this down at the bottom with the other ones that were cheating, because we did say at the start that we wanted whole numbers. However, it is nice to see that if we relax that condition, we can still find things as well. 2, 4, 4, 4, 6. That's a nice one.
Okay, when you say that's a nice one, Alison.
Yeah, and 3, 6, 6, 6, 9. I'm going to put that here as well. In fact, I'm going to swap the orders of these around a little bit. And and put that one under there, that one there, that one there, and then I'm going to leave a gap and put that one there, and see if anyone can suggest what I might want to put in my gap. And of course, this is the advantage of a virtual whiteboard over one in the classroom, because in the classroom, if I wanted to move where I'd written things, I'd have to rub them out and move them. Although, Charlie, I know you've occasionally written things on large pieces of paper and stuck them up on the board so that you can have this moving around effect.
Yeah, blue tack has come in very useful there.
Yeah. Okay, some of you have spotted the missing one, which was 4, 8, 8, 8, 12. And a couple of people have started trying to generalize this. So Jack has suggested that we can have n, 2n, 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 and 3n. Do we want to check that we're happy that that gives mean, median, mode, and range the same, Charlie?
Well, the range is the difference between 3n and n, so that's 2n. And I can see that the mode and the median are both 2n. So the only thing I'm left to worry about is the mean. If I add them all up, I get 10n, and 10n divided by 5 is 2n. So yes, the mean, mode, median, and range are all 2n. And the lovely thing about this is that once we've got that generality, we can now produce as many sets of 5 positive whole numbers that where mean, mode, median, and range are all equal, that satisfy this particular condition. And obviously it's not the only one, because of course, my first example, 2, 5, 5, 6, 7, didn't fit this condition. And then the other one that is that you wrote next to it, 3, 4, 5, 5, 8, is yet another arrangement. But we can find lots which satisfy the n to n to n to n 3n condition. So if I wanted the mean, mode, median, and range to be 100, and I wanted the 5 numbers to satisfy this condition that Jack has posted, what would the 5 numbers be? Alison, I wonder whether we could have a new page on your whiteboard and copy the n to n to n to n 3n onto it.
So you want n, 2n, 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 and 3n. And you wanted to find a set where the mean, mode, median, and range were all 100. Is that right?
That's right. And a few people are posting.
I think Indika had a hypothesis and then corrected themselves there. So we have to be very careful with the what our n is in this case. So because you said the mean, mode, median, and range needed to be 100, that's 2n equals 100, so n equals 50. So 3n is 350. Yep, few people have got that now.
Okay, could you add that to the board?
Okay.
And can you bring that down to the middle of your page?
I can do whatever you like, my dear.
Thank you. Okay, so I'm just going to note that I could use this as my starting point. I'm going to try and draw. And I could use this to then come up with other examples where mean, mode, median, and range are 100. So I could take 1 away from the 50. Here we are. I could take 1 from the 50 and get 49. And if I still wanted my mean, mode, median, range to be 100, then the largest number would have to be 149. Otherwise, my range is not going to be 100. And if I want my median to be 100, then this middle number is going to have to stay the same. And if I want my mode to be 100, then I'm going to have at least two 100s. So I'm going to keep this 100 as it is. So now I've got a range of 100, a mode of 100, a median of 100. I still want a mean of 100. So I want the total of my 5 numbers to be the same as the total of these 5 numbers. These have stayed the same. I've made this number 1 smaller. I've made this number 1 smaller. So I think all I need to do is make this number 2 bigger. So I'm not even going to bother adding all the numbers to make sure they're up to 500. I'm just going to compare one list with the other and then be able to know for sure that the mean is going to be the same. So the challenge I'd like to set to you is this. How many other combinations of five positive whole numbers do you think there are, where the mean, the mode, the median, and the range all equal 100? So m equals m equals m equals, I'm going to leave Alison to do it. She's going to be faster than me. Thank you, Alison.
I hate seeing you struggle.
So we've used Jack's generality to produce 1, but we can use that as a springboard for finding others. I started by taking 1 from the 50 and then working out what the other 4 numbers had to be, but I could have added 1 to the 50. I could have gone in the opposite direction. How far can I go in each direction? How many different combinations? What's the smallest number I could start with? What's the largest number I could start with? Could you use the chat to share your thoughts and ideas? So,
good question, Jack. Yeah, let's stick to positive whole numbers for this. Although you might like to think about what would happen if you tried to include negative numbers as well. Indika suggested that we might be able to go down as far as 25. So I'll say exactly what I would say to a student in this case, which is, why don't you try it? See if you can find a set of numbers, which is 25, and then 125 as the biggest number, and then 100 as the median, and then another 100 in there for the mode, and then work out what the other number will have to be in order to make the mean equal to 100. I think I tried 25 when you gave me this problem when we were planning this, didn't I, Charlie?
perhaps, but you know what my memory's like these days.
I can see why 25 would be a good thing to want to try first. Well, should we try it? Should we try what happens if you put 25 in first? So I'm going to have 25. Just getting my pen. 25 as my first number. So I've got to have 125 here. I've got to have 100 in the middle to be the median. I need to have another 100 in there as well for the mode. And so my total so far is 100, 200, 350. So to make a total of 500, so the mean is I would need to have 150 as my final number, which is bigger than 125. So it breaks the range. So although I can see why 25 feels like a good choice because it's like a half of 50 and it feels as if going for halves is the right thing to do. But unfortunately, that means that I go bust at the other end. So I'm going to rub that one out.
Can we try, well, Anum has suggested 34, 100, 100, 132, 134.
Ah.
So how do we know we can't go one smaller?
Yeah, I think that's actually, yes. So I think what's going to happen then is, if I wanted to go down to 33 and then down to 133 at the other end, then my total for the other three numbers would have to increase by 2. So this 132 is the only place I can put those extra 2, which would take it to 134, which would have then gone over. So yes, I agree with Anum that 34 is the smallest that we can go at this end. And that's also, I'm thinking 34, well, that's quite close to 33. I wonder if it has anything to do with the fact that 100 divided by 3 is 33. That's something I kind of want to go away and think about. Richard's found a nice example that's all multiples of 10. I quite like that. Can I write that one up? 40,
You can write that.
100, thank you, 100, 120, and 140. So this is the smallest example then. And then what could we do for the biggest example?
Before we do the smallest, Alison, Karen is asking about 1, 100, 100, 98, 101.
I don't think the total of those is going to give me the correct mean, is it?
I think the total adds up to 400 rather than to 500.
Yeah.
And Karen, a different Karen, has suggested what the largest number, and I think we can use a similar argument to the one that you used to show why that largest, the 66, can't go up to 67. Because if 66 goes up to 67, 166, the largest number would have to go up to 167.
And then the 68 would have to reduce by 2. In fact, there's some gorgeous symmetries here, Charlie, because I've got 34, I've got 34, 100, 100, 132, 134. I'm looking at this 132, which is 2 more, which is 32 more than 100, and this 68 here, which is 32 less than 100. And so being able to see both those examples together as the two extremes, I think is really rather lovely.
And the other thing that I notice is that we started with 50 on the left-hand side. 66 is 16 more than 50, and 34 is 16 less than 50. So the smallest number we can start with is 16 less from 50. The biggest number we can start with is also 16 away from 50.
And so altogether, you asked how many solutions there would be with whole numbers. And so we've gone down by 16 and we've gone up by 16 and we've got 1 in the middle. So there is 16 on either side and 1 in the middle. So that's going to be 33 combinations?
Yes.
Excellent.
Yes. And that seems quite a difficult question. The very first time one thinks about that question, one assumed it's going to be a really difficult question to answer. And one of the things we try to do with enriched problems is encourage students to work systematically by offering these kind of problems that challenge them to work systematically. And by working systematically and by setting out the work in the way that you did, and by moving the examples in the way that we did, and by noticing patterns, we've been able to answer a sort of a much harder question than one would have assumed one would be answering if we were just working on find the mean, mode, and median of these set of 5 numbers.
Yes, and I think we needed some real insights into how mean, mode, and median worked in order to find those examples. And we've whizzed through this in sort of like 25 minutes, whereas in a classroom, it might take a whole lesson, it might span onto more than one lesson. But the depth of understanding that you need to develop in order to answer these sorts of questions feels like it's going to start developing that intuition I was talking about that you need in order to be able to work with averages. Now, Charlie, I think you were going to share a page on the Enriched site to show the rope model that we
Yes.
were working on. So I'm going to stop sharing the whiteboard so that you can put that up. And while you're getting that up, I also want to just mention the idea of a generic example, because we could have gone algebraic on this. We could have thought of it as being a task for older students and put algebra straight in there. But I do like the idea of choosing a number like 100, which is familiar enough, but also far enough out of reach that listing all 33 of those combinations would have taken a while. And so using 100, we can do the general thinking that could be a stepping stone to some algebraic generalization on it. So it's sort of like a halfway house there.
Okay, so I'm going to share my screen, and I've waited because I want to show everybody how to get to the page we're about to show. But we will send the link to this page to Jane to share with everybody after the event. So don't panic if you forget. So I've got on the secondary teachers page on right now, and I'm going to go to a previous feature that we published in the summer. So I'm going to click on previous features, and the previous feature that we're going to show you is the one that we published on nurturing successful mathematicians. And along the feature, along with some problems that we published this article on nurturing successful mathematicians, and we introduced, I'm going to just enlarge this a little bit, we introduced these 5 strands, which Alison's going to talk about, that we developed based on the work that Jeremy Kilpatrick had done on mathematically proficient mathematicians, and we've turned that into the child-friendly language. Is that the right size to be displaying, Alison?
That's fine. I can read that fine. I hope everyone else can too. I've just popped the link in chat as well to this page, so you can open it and look at it on your own screen if you want to. So the idea of Kilpatrick's model is that maths isn't just about sort of learning new content and being fluent in it. It was actually 5 interlinked strands, and we've been using this model when talking in professional development for years and years, but we only ever talked about it with teachers. And so this model that we developed earlier this year gives us a language for talking about that with students. So we have the idea that maths is a network of linked ideas, and I can connect new mathematical thinking to what I already know and understand. And we call this understanding. And so in the task that we've just been working on, this is being able to understand what the mean, median, and mode and range actually are. And then tools, I have a toolkit I can choose tools from to help me to solve problems. Practicing using these tools helps me become a better mathematician. So this is linked with the idea of fluency, but also the tools that you need to be a mathematical problem solver. So you know, while working on the problem and selecting what calculations they need to do and how to do it and so on, students are building up their toolkit. And then there are problem solving and reasoning. These are 2 very closely linked aspects. So problem solving is an important part of maths, using understanding skills and reasoning to help me work towards solutions. Well, I think the task we've just been looking at is riddled with problem solving. There is a problem which is posed, and we're encouraging students to come up with their own ways of moving towards a solution. And then reasoning, maths is logical. I can convince myself that my thinking is correct, and I can explain my reasoning to others. By collecting everything together on the whiteboard and challenging each other's solutions, then that reasoning is going on. So somebody suggests x, 2x, 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 and 3x as a possible solution. And there's the opportunity for that classroom debate of, how do you know? Convince me. And so, yeah, that feels like something that is very present in this task. And then finally, the attitude strand. Maths makes sense and is worth spending time on. I can enjoy maths and become better at it by persevering. So this is all to do with mindset. And I guess our suggestion would be that working on problems that have a little bit of intrigue to them. The fact that to start off with, it was, can you find one example where the mean, mode, median and range are the same? And then by the end of it is, can you find every set of examples where the mean, mode, median and range are 100? And the generality of thinking in that, which means that a kid could walk out of the classroom door, say, you know what, I'm pretty confident I could go home tonight and find you a set where the mean, mode, median and range were 1,000,000, and I could tell you how to find all such sets of numbers. So that feels as if it's exciting and it's going to contribute to a positive attitude to mathematics. What are we going to do next, Charlie?
Yes, I mean, linking out to what Alison just said, the fact that we saw patterns, that there was that symmetry of going beyond 50 in both directions at the same amount, seems quite satisfying. And mathematicians obviously are always looking out for patterns. But the fact that there's that order that mathematicians find satisfying, and we want students to experience that as often as possible. Okay, so I'm going to go back to the secondary teachers page, and this time I'm just going to reduce the size of that a little bit, and this time I'm going to go to our secondary curriculum resources, and I'm going to scroll down. We're working on handling data resources, and we're working on statistics right now. So if you come down here, you might see a link to MM&M that some of you may have looked at before today. And I imagine Wipeout might be here. There it is, which again, some of you looked at today. But this afternoon, we've been looking at unequal averages. So I'm going to click on that. I'm just going to enlarge it a little bit. I'm going to hide the menu, and I'm just going to, sorry, back to unequal averages. Okay. And you can see the 2, 5, 5, 6, 7, which is the beginning of unequal averages, which is what we've been doing. But I want to look at what follows. And in what follows, I'm just going to make it a bit larger. Can you see that?
Yeah, that's great.
Okay. In what follows, we ask, can you find 5 sets of positive whole numbers that satisfy the following property? So we're not looking for equalities anymore. We're looking for inequalities, and we've put range to one side. So can you find 5 positive whole numbers where the mode is smaller than the median and the median is smaller than the mean? Where the mode is smaller than the mean, and so on. You can see. So we've done a lot of work on mode equals median equals mean. Here's a chance to, again, use the 5 strands that Alison was talking about with a slightly different problem. And what we'd like to do is give you a few minutes to think about it. Perhaps don't post anything on the chat immediately, but work on it for a couple of minutes, and then in a couple of minutes, you can start sharing. There's no reason why you should do the questions in the order in which they appear on the screen.
No, one really good technique for this is just to write down a set of 5 positive whole numbers and then just work out what the mode, median, and mean are and see which one of them you've managed to achieve, and then you get your first one for free almost. Okay, people are ready to start sharing suggestions in the chat now. So I need to check what's come in and then also write some of these up. So do I agree with Katie that 1, 1, 2, 3, 8 has the mode less than the median and the median less than the mean? Well, let me write it up. once Charlie stops moving the screen around. Is this
I
so that
didn't-
you can see the chat?
Yes, I can't find the chat. It must be, no.
So Katie had for A 1, 1, 1, 2, 3, and 8. Well, the mode is definitely the smallest there because it's 1. The median is 2. And then I need to work out the total for the mean. So this is 11, 12, 13, 14, 15 divided by 5 is 3. So yes, the mode's less than the median and the median's less than the mean. And in fact, there's quite a few suggestions now for the mode less than the median, less than the mean for A. Karen has started off in the same way with the 1, 1, 2, and then put some bigger numbers in. And when we were talking about this, Charlie, we talked about the idea of if you're trying to make the mean big, all you have to do is put one really big number in, and you don't even have to add it up. You can just say, I know this is going to make the mean the biggest of the 5 numbers.
Yeah, so if instead of 8, you added, next to the 8, you added a couple of zeros to make that 800, you could then save yourself the trouble of having to add the numbers and divide by 5 straight away.
Yeah, because the mean for that is going to be approximately 800 divided by 5, because it's going to be 800 and something small divided by 5. And I know that 800 divided by 5 is 160.
Yes.
Yeah, so the mean is definitely bigger than the others. Okay, so we've had quite a few people for suggesting things for A now. What else has come in? We've got one for D there from Richard. So 3, 4, 8, 10, and 10. So let's check that. Well, the mode is definitely 10. The median is 8, which is less than 10. And then for the mean, 20, 28, 32, 35 is 7, which is less than 8. So yes, I agree that the mean is less than the median and less than the mode. This is, I didn't realize, Charlie, when we planned this, that I was going to end up doing arithmetic in front of an audience. You know, I don't like doing arithmetic in front of an audience.
It's interesting that those 2 examples that you've chosen have got mean, mode, and median, which are all whole numbers.
Yeah, I guess it's sort of tempting to make things whole numbers because you sort of know where you are with them. But it would be interesting to see whether that's what students would do as well. Mode less than mean, less than median. That's B, isn't it? So Sharon's got one here. 3, 3, 5, 6, and 7. Shall I check that? I think what I would do in the classroom with these, Charlie, is I would write them up on the board, but then get students to check them. And then one thing that we've done before is to get them to come out and just put a little tick next to something as they've checked it to say, we as a class agree that this is correct.
Or we've also asked students to come up to the board and put a smiley face. And when there are 2 smiley faces next to any example, then we're reassured and the class can sort of have confidence that that might be good. And then if there is a problem, then we put a slightly sad face and somebody comes and corrects it.
I think I agree with that one, so I'm going to draw a smiley face. Thank you, Christian. Okay, well, we feel as if we're sort of 50% of the way there because we've got something for A and B and D. Has anyone had any success yet with answers C, E, or F?
Somebody's got one for F, Alison.
Oh, brilliant.
Elizabeth, 2, 3, 5, 10, 10.
2, 3, 5, 10, and 10. I think it's your turn to check this one, isn't it?
Okay, well, the mode is 10. So that looks like it's going to be the largest. The median is 5. So I'm hoping the mean is going to be somewhere between 5 and 10. If I add all these numbers there up to 30, and 30 divided by 5 is 6. So the median is, sorry, so the mean is in between the median and the mode. So smiley face, please. So we've just got two missing. Both of them got the mode in the middle. Oh, I got very excited. Karen had got one for E, but she said she's put the wrong letter. So, okay, so we got it. We're still waiting for an example for E.
Well, one thing that I might want to draw students' attention to at this point, if we were doing this in the classroom, is that we don't know for certain if it's going to be possible. So you've kind of got two options at the moment. You can either try and find something where the mean is less than the mode and the mode is less than the median, or you can try and come up with a convincing argument for why it is impossible to find such a set of 5 positive whole numbers. So I wonder whether anyone can come up with a reason why they might think it's impossible. So Christian, you said that the mode has to be either the first two or the last two. I wonder if you can expand on that a little bit and tell us.
I wonder, Alison, this might be quite difficult.
Well, we've just had a suggestion from IFSA who says that if the mode is not the first two or the last two, then the mode will include the middle number, and then the mode and the median would be the same. So the mode has to be either the first two or the last two. So that means that the median has to be higher than the mode, or the median has to be lower than the mode. So all we have to do now is to work out where that puts the mean relative to it. So I think, yeah, Jack is just about there. I think the way that I explained this was that I thought about trying to make it, and I thought, well, I'm going to have my set of 5 numbers. So here's 5 spaces to put it in.
Can I just check, Alison? Are you're doing C rather than E, aren't you?
Is that the one you want me to do? C. Yeah.
Okay.
I think you can do the sort of like the same argument for both. Sure.
Yeah.
And so I have some number in the middle for the median. So let's pick an example. Let's suppose I put 30 in the middle for the median. Nice big number there. Now I want the mode to be less than the median. Okay. So that means that these two numbers here have to be less than 30. So I don't know, let me pick 29 and have that twice. So I've definitely got that the mode is less than the median. But these two numbers here, whatever I put here and here, has to be bigger than 30, because otherwise 30 won't be the median. But if these numbers are bigger than 30, then it means that the mode is going to end up also being bigger than 29, because all of these 3 numbers are bigger than 29. So the mean will be bigger than the mode, and then we'll be in situation B instead of situation C. Did that make sense? Can you put that into words that make sense, Charlie?
Well, if I've got 5 30s, can we write just below your 29, 29, 30, arrow?
Okay. If it was 30, 30, 30, 30, and 30.
Now I know that the mean is 30 here.
Mm-hmm.
And I know that the median is 30. Now, if I make the 2 first numbers smaller and I make the 2 larger numbers bigger, I'm not going to be able to get a mean which is smaller than 29, because I'm going to get a total which is going to end up being...
It's got to be bigger than 5 times 29, hasn't it? If all the numbers are 29 or more, then as soon as any of them are more, the mean is going to be the biggest. So yeah, I think with that, I think we've proved that C is impossible. And then in the same way, you can prove that E is impossible, but instead of it being the two smallest numbers that make the mode, it's the two biggest numbers that make the mode.
Yes.
Cool.
It's perhaps surprising, but it is possible to satisfy both C and E if we allow everyone to use 6 positive whole numbers. Should we give everybody a minute to try and do that?
Yeah, okay. So pick either inequalities C or E and see if you can use 6 positive whole numbers instead of just 5, whether you can get either C or E to work. I suppose the difference when you've got 6 numbers rather than just 5 numbers, Charlie, is that you've got sort of like an extra degree of freedom for where those numbers can go. So with 5 numbers, once we'd positioned the median, we were forced to have the mean as the mode as either the 2 below it or the 2 above it. But for 6 numbers, the median is going to be the average of the 2 middle numbers. And so I could have, if I imagine my 6 numbers, I'm running out of space on this screen, but I'll just write it up here. If I've got my 6 numbers that I'm trying to position, I could have the same number repeated there and there to be the mode, and then a different number here, let's call it Y, to be, and then the median will be whatever number is halfway between X and Y. And then I've still got 3 numbers to play around with in order to choose what my mean is going to be. So it just feels as if all of a sudden I've got much more freedom. And Katie suggested one that you can check for us, Charlie, 2 for 20, 24, 25 and 25.
And that's for E. Do you want to write it next to the E condition for us?
I suspect the mode is going to be the biggest for this, isn't it?
Yeah, well, the mode is definitely bigger than.
I think the mode's going to be bigger than the mean because I've got 6 numbers. That's for C. Okay.
Okay.
So yeah, right. Yeah, for C then. Okay, so I've got 2 for 20, 24, 25 and 25. So the mode, the median is less than the mode then in that case.
Alison.
Yep.
I was looking at what you were talking about a minute ago.
Mm-hmm.
If you go back to the bottom right hand of your whiteboard where you've got 29, 29, 30, arrow, arrow.
Okay.
And you add a 6th place before the 29s.
Okay.
Because the struggle here was to get the mean to be really small. So if
I put like a 31 and a 32 in my 2 spaces after the 30 then?
Yes, I can then put a really small number which will drag the total down.
So if I put a 1 in there, will that drag it down enough?
Yes, because I've got the median and the mode are close to 30.
Yeah, so it's going to be 29 and 29 and a half.
Yeah, and the total is going to be close to 5 30s instead of 6 30s. So it's going to be well below 30.
Yeah, and I can see that Jack is using that idea of putting a massive number in there in order to drag the mean up from where you want it to be, which is always fun. I think what's happening with all of this then, and I'm actually going to stop the screen share now. This is what I was sort of alluding to before about the idea of being playful with distributions in order to start gaining familiarity with how changing some numbers changes the averages. So this idea that you've got a set of 5 numbers that nearly does what you want it to, and so you just change one somewhere. But of course, that isn't really how averages work in the real world. Unless you happen to be a government statistician, of course. You don't get to choose the data sets that you're working with. You're given the data sets and you have to interpret them. But I think the idea that I want to get across is that working on something like this helps you to understand how changing a distribution changes the mean, median, and the mode. So then when you're looking at a set of real world data and you're given mean, median, and mode, you've got more of an understanding of what you mean. And so as well as working with these small data sets with a question like this, I think it is important also to think about what happens if the numbers are bigger and the data points are bigger. There was something that I didn't really appreciate until quite a long time into it. It's one of these things that you're sort of embarrassed to admit just how old you were when you first realized it. And that was that if you know the median, you know that 50% of data points are below that and 50% of it are above that. And that feels like such a useful concept that wasn't made clear to me until quite a long way through my education. And I think that also made it difficult for me when I first met the idea of quartiles and the interquartile range, and then box and whisker diagrams as well. The idea that the key thing a box and whisker diagram is showing you is that 50% of the data is within the lower and the upper quartile just feels like such a powerful idea to me. It's giving you a better sense of what the distribution is doing than just knowing something about the mean or the median or the mode. It's also sort of tending towards the way that averages relate to other topics in maths. So again, I was far older than I'd care to admit when I first realized that the idea of a center of mass in mechanics is just about an average. It's asking what the central point of a particular object is. So it's saying on average, where is the gravity acting? And once I started making the connection between mechanics and statistics in that way, I found it really helped my understanding. So I think it's probably a good time for us to look at another problem now. So I'm just going to bring this up on a screen share.
While you're doing that, Alison, can I just reflect on what we've done so far in terms of the kind of classroom that you and I are picturing when we get classes, students to work on tasks like this. The fact that we've been able to use the chat to share ideas feels like it's been quite a collaborative exercise. And this kind of problem offers the possibility of interacting like that with students in a classroom. We're engaging on a shared task that we all understand, and we can all contribute to. And as people go contributing, people go noticing. So when Alison was adding things to the whiteboard, and then somebody noticed, for example, that it was an end to end to end to end to the end kind of pattern, it becomes a conversation that we can all have in the classroom, share insights, and it becomes less of a private kind of activity that we each do in our exercise book. And I think this transforms the classroom into, I mean, Alison and I didn't know exactly where we were going to be heading after our starting points. We'd rehearsed possible journeys, but of course, we tried to react to what was posted in the chat in the kind of way that I imagine you're trying to do in your own classrooms. And that we hope that your students feel that you're engaging with their ideas and so on. And I'm reminded of the work of Elena Nardi, who said that, you know, students found maths lessons tired. She used tired, the T for tedious, I for isolated, students working on their own. R was, I think, perhaps about rote learning. E was to do with being elitist. You either were good or you weren't. But the D of tired was depersonalized. They didn't get a chance to share their ideas or to feel that their ideas were valued. And if we want students to leave our lessons with a positive attitude that Alison was talking about when we were looking at the 5 strands, that seems really important. So I think it's, when we're thinking about rich tasks to publish on Enrich, then we are thinking about the kind of classroom and how students and teachers can interact.
And I think that's also what you're trying to do with the teacher's notes on a task on Enrich as well, because you're trying to take some of the work out of it. So when we were planning what might happen for each of these tasks, we were using the teacher's resources as guidance for what we would expect people to come up with in the chat and where the lesson might go, so that it's not a case of going in completely cold and not knowing what's going to happen. We had some ideas of the sorts of things that might happen, and sure enough, the things that we expected actually did happen. Okay, I'm going to share then, hope you can all see, for richer, for poorer. So this is a prompt that could be used to start thinking of this idea of averages when you've got larger data sets. And in this case, we don't actually know the size of the data set. We've just been told that there's a rich country called Emerald where the mean income is 20,000, and a poorer country called Flint where the mean income is 16,000. And then we've got this character called Charlie who lives in Emerald and he earns 18,000 a year. And he moves from Emerald to Flint. And he says, I've made both countries richer. And so the question is what Charlie might mean by that, and whether you can convince yourself that Charlie is right, that the mean income of both countries has increased by him moving from Emerald to Flint. So give you a moment to think about that and to suggest in the chat how you might justify whether Charlie is correct or not. So Charlie, do you have a story to tell then about how you know that, I'm assuming it's you, the Charlie who thinks that he's right in this scenario?
I suspect that you and I wrote this problem together, Alison.
So how do we go about convincing ourselves that the move from Emerald to Flint of someone who earns, it looks like halfway between the average for Emerald and the average for Flint, how can we be certain in this case that it makes the average go up for both of them?
I suppose one way of thinking about Emerald, where the mean income is 20,000, is that everybody in the population of Emerald could be earning £20,000. So we don't know how many people there are, so we don't know what the total income is. But if everybody earned 20,000, then the mean income would be 20,000.
So if Charlie's earning less than 20,000, if he's only earning 18,000, then that means that there's sort of another person, let's call them Alison, who would have to be earning £22,000 in order to cancel out how shamefully below average Charlie's earnings are. Yes?
And so then when Charlie leaves Emerald, there are all the people with 20,000 plus Alison overpaid at 22,000. And so when we work out the average of all those 20s and Alison's 22,000, it's going to be just a little bit more than 20,000, unless there were only 3 people living on the island. Well, is it an island? No, in which case the total would go up to 21,000. But whatever happens, yes, the income, the mean would go up.
And I think what I like about what you've just done there, Charlie, is that you've taken some actual numerical examples to give you something to sort of anchor the thinking. And in order to sort of formally prove this, this is tagged as a age 14 to 16 2-star problem. So it's for older students, and it's intended to have a level of challenge to it. So we would want to come up with a slightly more formal argument, and we might need to start introducing some unknowns to represent what's going on. But that informal argument, just using numbers to start off with, gives us a sense of what's going on that we can then use to develop the more formal argument. And I think you can come up with exactly the same sort of argument for Flint's average increasing by someone who's earning above average moving there. And so, yes, it's exactly that, Indika. It's this idea of when you're taking away a number which is less than the mean's going to get bigger. And if you take away from the data set a number that's greater than the mean's going to get smaller. Now, there are some follow-up questions on the site. I know that we are running a little bit short of time, so these might be ones to go away and think about after the webinar. But it goes on to say, what would need to be required in terms of the mean income and Charlie's income for each country if his move increased the mean income in both countries? Is there a way to make that happen? Decrease the mean income in both countries? How could you make that happen? And how could you increase one while decreasing the other? So again, it's all about getting students to think about what happens to the average, the mean of a data set when you make these changes. But there is something that isn't currently in this problem that I'd rather like people to also consider, which is, what would you expect to happen to the median in each of these cases? And I think I'm going to leave that thought there and come back to it in a few minutes' time, because I know that Charlie, you wanted to mention the problem wipeout and also show us how to get to the statistics area of the mapping document again.
Before you remove that page with those 3 follow-up questions, Alison, I think one of the things I want to say is that when we think about enriched tasks, we're not thinking about tasks that need to be done after students have done all the textbook questions, asking standard questions about mean, mode, and median, and so on. That we think, and the 5-strand model that you were talking about, Alison, we're trying to integrate the need to have the conceptual understanding, the need to understand the tools required to work out mean, mode, and median, at the same time as requiring students to reason, which is what we were just doing, and solve a problem, which is what we're being asked, what we're giving students to do. And that this is what makes this a rich activity. And because the answer is not immediately obvious, there's an opportunity to work together, to discuss, to share ideas, to conjecture, and so on. And perhaps to notice some general cases. So there may be lots of examples where we can increase the income in both countries, or where we can increase the one in one and decrease in the other, and so on. So when we look at rich tasks, we are thinking about that 5-strand model, and that seems a much more interesting way of engaging with mathematical problems. I'm going to go to handling data and stage 3 problems on statistics and wipeout. Now, I'm aware that not everybody will have looked at this problem before today, but some of you might have done, and you might have wanted to prove that if you have an even number of consecutive numbers, like 1, 2, 3, 4, 5, and 6, but it could be any number of 6 consecutive numbers, and you wipe one of the numbers out, you have to wipe out one of the numbers at the two extremes if you want the average to be a whole number. And I think what Alison's asking me to do is maybe prove that this is the case. So let's imagine I've got all the consecutive numbers from 1 to 100. So I've got 100 consecutive numbers. If I wipe out the number 1, I've got 99 consecutive numbers. And so the middle number will be, I think, the 51st number in the sequence. It'll be 51. And I've got an equal number of numbers before and after that. So the average of all these numbers is going to be 51. But if instead I'd wiped out the 100, then I would still have 99 consecutive numbers, but the middle number would have been 50. And so the mean of all these numbers would have been 50. And so if I wipe out the smallest number, I get a mean of 51. If I wipe out the largest number, I get a mean of 50. If I wipe out any other number, the mean is going to be somewhere between 50 and 51. There are no whole numbers between 50 and 51. So the only way to get a mean, which is a whole number, is to wipe out one of the extremes. Okay.
And I guess a nice reason to do this problem when you're doing work on averages is because it's sort of highlighting this property that if you've got consecutive numbers, the mean and the median end up being the same. If you've got a consecutive number of an odd consecutive number of numbers, and it's also encouraging this playfulness with averages that we were talking about.
Okay, I went very quickly through that, but and we've gone quickly through quite a few of the examples, but we're assuming that you'll go back to the problems and have a chance to think about them again. So let me go back so that I can show you what Alison was asking for. So on this page, on statistics stage 3, we've got lots of problems that you might want to use with year 7s, 8s, 9s about statistics. And there are descriptions of each of the problems, but it doesn't quite give you a sense of, would I use this in year 7 or would I use this in year 9? When exactly might I use it? Though it does give you some idea about how what the difficulty level is. So the 1-star problems are more accessible than the 3-star problems. We don't seem to have anything. Here's a 3-star problem. So what Alison was suggesting is that another way of finding those problems is by going to the secondary teachers page, clicking on secondary, and then going to our mapping document. And here we have listed all those problems. So I'm going to go to the statistics section. And here we've listed same problems. So you can see MM and M there. You can see wipeout here. You can see unequal averages here. So what we're suggesting is here's a year 7 column, a year 8 column, a year 9. We haven't quite labeled it year 7, 8, and 9, but it starts at age 11. It finishes at age 16 with an extension, because of course, depending on which class and depending on your syllabus, you may want to do things in a slightly different time. But we're suggesting that M and M is a good problem to do at the beginning of Key Stage 3. Wipeout might be a good problem to do towards the end of Key Stage 3, and unequal averages might be a good problem to do towards the middle of Key Stage 3. And we've got this mapping document that regularly gets updated as we add problems. And a lot of schools are using this to populate their own scheme of work with enriched problems. And we've got a similar page for geometry, for algebra, for number, this is the statistics and probability page. I think that's all I want to share right now. So I'm going to go back
Lovely.
to Alice.
Thank you very much, Charlie. I parked a thought a few minutes ago and I want to pick it back up again because it feels like a good thought for people to take away with them. And that's the idea that we were talking about how changing, when Charlie moved from one country to the other, the mean changed. And I just threw out the idea of what would be different if we used the median instead. And I'm just going to share a link in the chat. It's to an article that is quite old now, unfortunately, but that I think makes a really interesting thing with older students to look at. It's about the difference between salaries and house prices. And certainly this is something that, you know, students might be aware of thinking about. I think quite a few younger teachers are very aware of the gulf between salaries and house prices. But throughout, in articles like this, you always get the quoting of the median average house price and the median average salary. And I think it's really useful to talk to students about why articles like this and why the national statistics and so on always look at the median rather than the mean. And you could even look at local house prices in your area where the school is, which again is really quite an interesting thing for students to do if they've never really thought about how much a house costs. You can look at house prices and think about if somebody moved to the area and built or bought a multi-million-pound mansion, how would that affect the average house price in the area, and how does that differ if you're using the mean average or the median or the mode? And so in the same theme, I also want to share a link, which I'm putting in the chat, to something called Quibans, which are questions inspired by a news story. So this is a website that Mark Dawes set up. And it finds examples of things that have appeared in the media that could be used to inspire a starter or a longer period in a maths lesson. And quite a lot of the news stories are about averages or misuse of averages or choosing the wrong average, and lots of other things about estimation as well. And he's got a really useful spreadsheet on the website with all of the different Quibans that he's written so far, where you can then look at it and find what topics it is. So you can find all of the ones on average in there. The other links that I wanted to share then, I just wanted to remind everybody of how to stay in touch with us after the webinar. So I'm putting a link in the chat to my website, which has a contact form if you want to get in touch with me. And I'm also going to put a link to my Twitter feed, because the best way to know what I'm doing is the fact that I most of the time, if you want to know what Alison is up to, Alison is updating Twitter. So a couple of ways of keeping in touch with me if you've got any follow-up questions for me afterwards. And Charlie, would you like me to put in a link to the Enriched newsletter and Twitter feed as well?
Well, just before you, I'm going to just share my screen, and so that I can just show everybody that where to find. So I'm hoping you see. So that's the Enriched homepage, but any page at the bottom here has an invitation to join our mailing list, and we only send information about maths events once every half term. And if you want to contact me, I'm the secondary coordinator, so any secondary inquiries come to me, and there's an email there at the bottom of that page, and that appears at the bottom of every Enriched page.
Right, well, that brings us to 5:30. Thank you ever so much, everybody, for getting involved and everything that you've put in the chat. It's been really lovely to talk about averages with you today. And yeah, get in touch with us if you've got any follow-up questions. Anything to add, Charlie, before we hand back to Jane to say goodbye?
No, thank you, Jane, for organising this. We may see some of you next term. We're going to be doing something on, I think, patterns and sequences in a similar style to how we've done this. So if you've enjoyed today, we'd love to see some of you back again. And yeah, have a good Christmas break when it comes.
Amazing. Thank you so much, Charlie and Alison, for such a valuable session. Thank you all so much for coming and participating, and I really hope you enjoyed it. Thank you.